Okay. So what we're going to do, I do believe it's going to record on the paper. I don't know if you can see my face, but I am going to be talking about inverse functions real quickly. Uh, there's going to be notes that are posted with this video. You can fill them in as you like, and then I will post these. Just to recall from algebra, a function is represented as a set of ordered pairs. For instance, the function f of x is equal to x plus 3 has the x values of 1, 2, 3, 4, and b is 1, 2, 3, or 4, 5, 6. Then the coordinate points, if I plug in 1, 2, 3, is going to give me those function values. So we're going to look at an inverse of a function, and an inverse of a function means that these are composite functions, and that's what we just got done doing with the chain rule. Um, that the composite function, and if I write it backwards, the inverse of the function is going to give you x. Thus, the domain of f is equal to the range of f prime, or excuse me, the inverse and vice versa. So for instance, let's just jump right into this. I want to show that these two functions are inverse functions of each other. So if we look at x and y's, and we plug in 0, 1, 2, and 3, we get 0, 1, 4, and 9. All right. So 0, 1, and I just kind of abbreviated what this looks like. Obviously, it comes over to this negative side, but the main part of the function is that one. If we look at the x and the y here, basically what's happening is the y's now become the x's, and the x's become the y's. So that when you're looking at this function becomes that graph. And then what happens is, because it is equal to x, the line is symmetric over or the graphs are symmetric and reflected over the line y equals x. So anything that is on a coordinate of here, 4 comma, 2 comma 4, then is going to be the reverse of this, and 4 comma 2. Now, the inverse has to be 1 to 1, which means it has to be has to pass the horizontal line test. A function has to pass the vertical, and inverse has to pass the horizontal. Okay, so that's where we get inverse functions. So function is an inverse if and only if it is 1 to 1. It's monotonic, which means it's continuous over the entire domain, and therefore has an inverse. To find the inverse of a function, so let's quickly just find what an inverse function is. So let's just say I do have y equals x plus, let's go 2x plus 3. So the first thing that we're going to do is we're going to replace and put x's in where the y's are and y's where the x's were. And we're going to solve for y. So we're going to subtract 3 and divide by 2. So we get x minus 3 divided by 2. You can split this up. This would be the inverse, which is denoted as f to the negative 1. So this is f of x is equal to y. And then what would happen is you would get that. Let me focus that in. That would be the inverse function. Okay. Now, if I were to take the derivative of that, let's say I take the derivative of this. The derivative of this is 2 automatically, which means that the slope at any point on there is going to be 2. If I take the derivative of this inverse, the inverse function derivative is going to be the derivative of this, which is 1/2. So notice these two are not negative reciprocals, but they are reciprocals. So they're just flipped, okay? So any point, let's go back up to this graph, any point on there, so if I have a slope here of 4, m equals 4, then what is going to happen is you're going to flip it and you get 1 over 4. Okay, so this one would be 4. This is a different graph. So if the slope here is 4, how did I get that? Well, the derivative of x squared is 2x, and the derivative at 2 is going to be 2 times 2, or 4. If I take the derivative of this, which is 1 over 2 square root of x, at 4, it's going to be 2 times the square root of 4, which is 1 over 4. So these are going to be reciprocals of each other. So that's where I get that. Pause there, ask questions if you need to, email me, etc. So the next one is evaluating a derivative of the inverse function. So finding the derivative of the inverse function. There are a couple ways to do that. And the couple ways to do that is if you have a generally easy function to look at, then what we're going to do is method 1. Excuse me for 1 second. Sorry, I had to cough there. So what we're going to do is we're going to find the inverse first, find the inverse function by interchanging x and y and then solving for y. 2, take the derivative of this new y. That will be the derivative of the inverse function. And then plug in the given value k, which is also the same value for x. So let's just kind of work through this. We're going to set this equal to x squared. So we're going to look at kind of the other function that we did before. So we're going to interchange and we're going to solve for y. So the inverse function is the square root of x. We just had that. That was the graph. So the part B is take the derivative of this new y. That will be the derivative of the inverse. Okay. So now what I want to take is the derivative of this function. And that is going to be 1 over 2 square root of x. We've done this derivative before. It is 1 over 2 square root of x. That goes on that cheat sheet that you're going to use. All right, and then we're going to plug in the value. So we're going to plug in of f, the derivative, in terms of 4. So that's going to be 1 over 2 square root of 4, which is 1 over 4. Now the other way to do that, if you think about it, it's not necessarily easy. If we know what f prime is, which is 2x, and we want to know where f prime is, well, this 4 means that it's the y value of this function. And the y value of this function, you're looking at x squared is equal to 4, so x is equal to plus or minus 2. Well, we use the plus 2. So we're looking at f prime of 2, which is 4, and then if I flip that, I get the reciprocal, which is going to be the reciprocal of the derivative at a specific point. Method 2. This method is usually used for a function that is a little bit more difficult to look at and a little bit less, you can't find the inverse really intensely. Okay, so the first thing that you're going to do is you're going to find the inverse by interchanging the x and the y. Do not solve for y. It's pretty much impossible. Not necessarily impossible, but don't do it. Okay, so step 1 is we're going to change the x's and the y's. So y cubed minus 4x, or excuse me, 4y squared plus 7y minus 1. Okay, that's part A. I guess it would be from up above. Part B is find dy dx implicitly. Okay, so implicitly means that I take the derivative of everything in terms of dy dx. 8y dy dx plus 7 dy dx, and the derivative of -1 is that. And we know from implicit differentiation, we're going to take 1 over, and I'm just going to group because this is all going to factor out the dy dx. And that's going to be 3y squared minus 8y plus 7. And if you notice, the derivative of that function is that bottom part of that function. So we're just kind of flipping it over 1. All right, so part C, solve for dy dx in terms of y. Part D is we are going to replace the value of k for x in your inverse function from step A above and solve for y. So what we are going to do is we are going to set this. So this is an x value of the inverse. It would be a y value of the function. So we need to set 1 equal to x cubed minus 4x squared plus 7x minus 1. Use your calculator or Desmos or something to find what that is. So x is equal to sorry, I zoned out there for a second. Sorry, we're going to plug this in to that one. These are going to change to y's. So 1 is equal to y cubed minus 4y squared plus 7y minus 1. And we're going to solve for y. And in this case, y is equal to approximately 349. And then we're going to plug it into this. So we're going to take this value and plug it into that value. And dy dx is going to be 1 over that plugged in, which is going to be some value over, so 3y, so 0.349. You can do it this way, squared minus 8 times 0.349 plus 7. And this is approximately equal to 0.218. So dy dx at 1 is 0.2187. So let's take a look at this one. The derivative of the inverse of f of x equals e to the x plus natural log of x at 3. X equals 3. So the first thing that we are going to do is we're going to switch the x's and the y's. We are going to find the derivative of x. So 1 is equal to e to the y dy dx plus 1 over y dy dx. So the derivative of e to the y is e to the y, and derivative of natural log of y is 1 over y, both with the dy dx. So dy dx, I'm going to kind of cheat a little bit here, and that's e to the y plus 1 over y. Okay, so that's part C. Part D is we're going to set 3, because x equals 3, to e to the y plus natural log of y. And again, your calculator comes into play in this. So your y value is 1.074. And then e, you're going to find dy dx of x or y, excuse me, y is equal to 1.074. And that is going to be 0.259. So the slope of the function, of the inverse function, the derivative of the inverse function at x equals 3 is 0.259. There is another way to do it, and that is using the composite functions. So if I look at f of g of x, and I set f of g of x, and I look at that function, let me make sure where my notes were, and I look for the derivative, and this is x, because if it's a function. So if I look for the derivative, it is f prime of g of x times the derivative of the inside, which is g prime of x is equal to 1. So g prime of x is equal to 1 over f prime of g of x. So g of x is the inverse of that function. So the inverse of that function. And they will usually say that g of x is equal to the inverse of the function. Okay? So just make sure that when you're doing those, you're looking at that correctly. So let's use that in terms of this. All right, so first thing to do is let's use the formula. So we get x is equal to y plus sine of y. We're going to we switch x's and y's. At x equals pi, y is equal to pi. The sine of pi is 0. So if I plug in pi, y is just pi. Okay. F inverse of pi is pi. So the derivative of x is 1 plus cosine of x. The derivative in terms of pi is 1 plus cosine of pi, which is 1 plus negative 1, which is 0. So the inverse derivative of pi is 1 over 0. That's 0. So that is undefined, which means that the slope at this point would be 0, which it is. So it's the flip of that. So that is the inverse. There are a couple other videos that you can probably find. If you didn't like this one, I am going to post that and post the answers, and I appreciate it, and we'll talk to you later.